Greetings, this is Dr. Gross, and welcome to another installment of Easy SPSS, an introduction into statistical analyses in IBM's SPSS statistical software package. And so I'm going to go ahead and open up SPSS on my desktop. When that splash pad appears, I'm going to close it. And we've previously saved a data set that we've been working with in this video series. And so I'm going to open that data set. I can go to File, Open Data, get there that way. Or I can click easier, my Open Data tab. And in Documents, I have saved the intro video SPSS data. So I'm going to go ahead and open that data set. And I can see the data set that we've been working with. And so today's lesson is an introduction to the one-way ANOVA. And so today we'll perform a one-way ANOVA in SPSS. What is a one-way ANOVA? It is a test used to determine if there are any significant differences between the means or the averages of three or more independent groups. So in our case, we're going to be interested in testing for different diet types to see if they have an effect on weight. And we already have weight as a variable, so we'll introduce diet type as a new variable, which will involve some coding. But it'll be a good refresher on SPSS, its basic views, and how to enter variables and data into the data set. And when would we use a one-way ANOVA? In the case where we have an independent categorical variable with two or more levels. In this case, we're using diet type with three levels: low calorie, balanced, and high calorie. And one dependent continuous variable. In our case, for our data set, we'll be using weight. And we want to compare weight across these three groups, these three independent groups. Or independent variable groups. In our case, we have a single independent variable, diet types, but it does have three levels or three groups within. So we're going to use this variable for our one-way ANOVA. And again, the goal of the one-way is to test for statistical significance in the differences in the independent variable across these three levels of the independent variable. So does weight, our independent variable, differ across these three levels of the independent variable? So does weight differ among different diet types, low calorie, balanced, or high calorie? So the first thing we need to do is give you a quick refresher on SPSS. This is data view, and I can access data view by going down here to my data view tab. And in data view, I see this spreadsheet-like formatting where each row represents a case or a participant. In this case, we have 12 participants. And each column represents the variables. In our case, ID, gender, height, weight, and then from the last video, we input a new variable, age. And so we need to then switch first to variable view. And in the first empty row, we're going to type diet type for the name of our new variable. So let's do that. I'm in data view. And I'm going to switch over to variable view. And in the first empty row that I have, row 6, in the name column, I'm going to apply a name for the new variable. And let's call it diet type. Remember, SPSS is particular when naming, so I can't put a space there. So I'm going to put an underscore in between diet and type. I could also use camel case where I'm just capitalizing the first word of each letter, but I prefer this so I can see it a little bit better. So I have completed that task. And then I'm going to set type to numeric and measure to nominal, since diet type is a category: high calorie, low calorie, or moderate. So let's set the type to numeric and the measure to nominal. So I'm going to go to my new variable, I'm going to set the type to numeric, which is the default. I don't have to do that. I have some decimals that I'd like to reduce to 1 decimal place. For the label, we can add a little bit of description. We can say high calorie, balanced, and low calorie. For our values, or let's continue with what we were doing. Measure, I'm going to set to scale. And now we need to add our code. And so for diet type, we'll use these codes. For a low-calorie diet, we'll represent it as a value of 1, a balanced diet, a value of 2, and a high-calorie diet, a value of 3. And so here is the data set to enter. And you can pause and enter that data set as seen on your screen. But first, I'm going to head back to my variable view. And I know what I want these values to represent. So I'm going to go to the values column and click on the ellipses, and that will bring up the value labels dialog box. And I have 3 independent groups or levels of the independent variable that I want to code for. So I'm going to add 3 values that I can apply labels for. And my values are 1, 2, and 3. And that's representative of a low calorie, a high calorie, and a balanced diet. So I'll add in those labels. 1 for low calorie, 2 for a balanced calorie intake, and 3 for a high caloric intake. Okay, so I've set those values, or I've coded my variable. And so I'm going to go back to data view, and I can see that SPSS has applied my new variable label. The name is diet type, the label high versus balanced versus low calorie, and then I can see my type and measure, which is set to scale. And now that I'm back in data view, I can manually input the new cases for our new variable into SPSS. So I'm going to go back to that real quick. Here's the data set to enter, and here's diet type. And I'm just going to enter my values, and I can always click my value labels button to see what these numbers represent. So pause the screen or pause the video on this screen right here and enter the data set as you see it into SPSS. And I'm going to go ahead and do that right now. Great. And I had the value labels switched on, so it's showing me what these values that I entered represent. And I can click on that values label to see, again, the values that I actually entered. And I prefer to keep this on. It gives me a better visual of the data set, gives me a better description. So now that I have my new data entered, oh, I always forget to do that. I'm glad I include this. I'm going to save this before I move on. And I'm just going to click that save button right there. And that saves my data. I can also go to File and Save. And if I hadn't already saved, this would be available to select. Save As would save it as a completely new file. So now that I've got that data set entered and saved, we need to check some assumptions for the statistical test that we will run. So there are some assumptions for a one-way ANOVA that need to be met. or satisfied before we run the actual test. So the first is independence of observations. And what this assumption is saying is that each participant's measurements or observations were collected independently, and that no participant influenced the observations of another participant. And that's generally verified through the design of the study and how you collect data in your sample. And so typically a good study design will satisfy the independence of observations assumption. Next is the normality of the dependent variable within each group. And so to check this assumption, and we're assuming here that the dependent variable should be approximately normally distributed within each diet group. So if we were to look at the cases within each group, that data should approximate a normal curve. And so to check this in SPSS, we'll go to Analyze Descriptive Statistics and then Explore. So let's do that first. Analyze Descriptive Statistics, Explore. Analyze Descriptive Statistics, Explore. And I'll see this Explore dialog box open up. And I'm going to move weight into the dependent box. And I'm going to move diet type to the factor list box. So weight to the dependent box, diet type to the factor box. So I'm going to move weight into the dependent box. And I'm going to move diet type, which I see now I've made a mistake with. I set diet type as a scale variable, and I've made mention that in variable view, it has to be set up correctly. Otherwise, SPSS will misinterpret as it runs these models. So diet type is a categorical variable, so I should have set that to nominal. Glad I caught that. So again, we're going to go to Analyze Descriptive Statistics, Explore. And again, I'm going to move weight into the dependent list and then diet type into the factor list. And next, I'm going to click on plots before I click OK. And when I click on plots, I'm going to select the normality plots with tests. So let's do that. I'm going to go to plots, and then I'm going to select the normality plots with tests and click continue. Once I've done that, I'm going to click OK. So what we're looking for, how do we interpret this test? What we're looking for is to see if the test called the Shapiro-Wilk test, if it is significant. So if the Shapiro-Wilk test value, or the p-value, the significance value, if that test value for the Shapiro-Wilk's test is significant, if it is less than 0.05, that is a violation of normality. So what we're looking for is that this test is not significant. And if it's not significant, we can conclude that normality has not been violated. And so in my output window, I will scroll down below the descriptives output box, and then I see my test of normality. So I'm looking at the Shapiro-Wilk, and for each group, low, balanced, and high calorie, I can see that none of the tests were significant. And so since the tests were not significant, I can conclude that normality was not violated. So I've checked off that box. The last assumption that I need to check is the homogeneity of variances. And this is assuming that the variances of weight should be approximately equal across groups, or diet groups in this case. So to check this in SPSS, we're actually going to have to run the analysis. We're going to run the model. But when we do it, we're going to click options and then select homogeneity of variance test. Now, when we run the ANOVA, we'll look at this test, Levine's test. And again, we're looking to see that this test value for Levine's test, or the significance value, the p-value, is not significant. So it's not less than 0.05. If it is less than 0.05 and Levine's test is significant, we violated the homogeneity of variances assumption. However, if the test is not significant, then we can assume that variances are equal across groups. And we'll come back to this, but first, let's run the one way in SPSS. So we need to check that final assumption, but let's run the one-way ANOVA because we can't check that assumption unless we do it. So we're going to go to navigate, or we're going to go to analyze and then compare means and then one-way ANOVA. So let's do that first. Analyze, compare means, one-way ANOVA. So now that I have my one-way ANOVA dialog box open, it's time to set up the variables. So we're going to move weight to the dependent list and diet type to the factor box. Let's do that first. Weight to the dependent list, diet type to the factor box. So weight into the dependent list, diet type into the factor box. Now I need to do one more thing. I'm going to click options and I'm going to select descriptives and the homogeneity of variance test. And then once I do that, I'm going to run the analysis by clicking OK. So I'm going to click options. And then I want to go to that homogeneity of variance test. You can also click descriptives. And once I've done all of that, I'm going to click OK to run the analysis. And so here's the output for my one-way. Above that, I had my output for my explore option. And in that explore option, I was testing for the assumption of normality, which was not violated. So we can assume the data is normally distributed across groups. And now I've scrolled down to my one-way ANOVA output, which is below. So let's go over that output. So you see a couple of important output from the ANOVA. You see the ANOVA table, and you can see the effect size table. And let's discuss the ANOVA table first. So in the ANOVA table, I'm looking for my F value. In this case, it's 5.831. And I can see that in my output box. So if I scroll to the ANOVA, I can see that my F value is 5.831. 5.831. Now, more importantly, the significance value, my P value. For this model, for this ANOVA, I can see that my F statistic is 5.831, and my level of significance is at 0.032. And since this value is less than 0.05, we can conclude that there is, in fact, a statistically significant difference in the average weight among different diet groups. Now, the next box we'll look at is the effect size. And we're looking at eta squared. And when I look at that output, and here's the effect size tables, I'm looking at eta squared, and I can see that the estimate is 0.625. You can see that right here. And how you interpret this is you would say that approximately 62.5% of the variance in weight is explained by diet type. So another way to say that is of the differences that we observe in weight, the type of diet can explain 62.5% of the differences that we observe. So that actually accounts for quite a bit. That's a large effect size. It suggests that diet has a substantial impact on weight. Now, we know that the model was statistically significant, but we don't know between what groups was there a statistically significant difference. All we know right now is that the model is statistically significant. So there is a statistically significant difference in weight among these three levels of the independent variable, these three diet types: low, balanced, and high caloric intake. So what these post hoc tests are going to do is they are going to identify, well, between which groups is the difference significant. So we'll again go to analyze, compare means, and then one-way ANOVA. But this time we're going to click and select post hoc tests. And we're going to select Tukey and Bonferroni, those two post hoc tests. So let's go back and we'll go analyze, compare means, one way. But this time, I'm going to select post hoc. And when my post hoc dialog box opens, I'm going to select Bonferroni and Tukey. I'm going to click continue. And then I'm going to click OK to run the analysis again. And what we're looking at, or what we're looking for, is we're looking for significant differences between these groups. Again, we're going to look at p-values to determine the level of significance. And as you can see in my presentation already, we do have significance, right? A 0.029 level of significance, it's lower than 0.05. And 0.037 also lower than 0.05. So let's look at our output for these post hoc tests and see. So in this dialog box, or this box, output box, multiple comparisons, we'll be able to see, all right, between which groups do these significant differences exist? All right, so I'm going to look at the mean difference column, and I see that asterisk. The asterisk is denoting a significant mean difference. And if I go over to the level of significance, I see the p-value at 0.029. Right? And that's what I cited you in the notes. 0.029 for Tukey, 0.037 for Bonferroni. So there is the 0.029 for Tukey, and the 0.037 level of significance for Bonferroni. And I noticed that the asterisks only appear on these numbers, which are the same numbers for the most part: negative 23.8, positive 23.8, negative 23.8, positive 23.8. So if I look at the matrix, I can tell where those differences occur. Right? And so the significant difference is occurring between low calorie and high calorie groups. There is a significant difference there, a difference of 23.8 units or pounds, right? And what this is saying is that the low calorie group is 23.833, repeating, pounds less on average than the high calorie group. And you can say that inversely by looking at the same number, it's inverse on the matrix. Again, this is comparing high calorie to low calorie. That is the significant difference between groups. And again, it's 23.8. It's not negative 23.8, but positive. Why is that? It's because it's saying that the high calorie group is 23.83 units repeating, larger on average or heavier on average than the low calorie group. I don't see a significant difference between any of the other groups other than the high calorie and the low calorie groups. So between low calorie and balanced, not a significant difference. Between high calorie and balanced, not a significant difference. Between high calorie and balanced, not a significant difference. And again, so the only significant difference is occurring between the low calorie and the high calorie group. And so what we can conclude based on these post-hoc results is that the high-calorie diet is associated with a significantly higher weight as compared to the low-calorie diet, while the balanced diet does not differ significantly from the other groups. So in summary, today we've yet again added a new variable, this time diet type, to our data set, and we've coded it. We checked and confirmed the assumptions for the one-way ANOVA. We conducted the ANOVA and found significance for the model. And we then used post-hoc tests to identify between which groups is that significance occurring, or that significant difference occurring. And we found through these post-hoc tests that the high-calorie group is significantly different in weight than the low-calorie group. And while that is true, between no other groups was a significant difference found. So using that approach, it allows you for a thorough analysis through the assumptions and the one-way ANOVA statistical model. Tune in next time as we explore various statistical tests in SPSS. Thanks for watching. See you next time.